Hi, this is Dr.S.Valliammai, Associate Professor, Department of Chemistry of Dr. N.J.R. Educational and Research Institute. See, in the previous slide of part 1, we have just explained about the amorphous nature of carbon. Okay, right? Now, this is the continuation of that. Now, in this, we are just going to see about the crystalline structure of carbon. So as I told you earlier, the crystalline structure of carbon has the very good examples are diamond and graphite. Now in this we are just going to see about the diamond and the graphite. Now let us move on to diamond. The crystalline form of carbon is diamond and graphite. Now diamond usually occurs in the purest crystalline allotropic form of carbon which is occurring in nature in the free state. Usually diamonds are found in South Africa, Russia, Australia, etc. So in nature, diamond occurs as octahedral crystals. Now let us see how artificial diamonds are manufactured. Now here artificial diamonds are prepared by heating pure sugar charcoal in and iron in a graphite crucible which is maintained at a temperature of 3000 degrees centigrade in an electric furnace. At this high temperature, carbon was dissolved in iron. So now the molten mass was cooled rapidly by just plunging it in a bath of molten lead and then treated with concentrated HCl. So as a result, we get the formation of artificial diamonds. Its structure. X-ray analysis has shown that the crystals of diamond is made up of a number of tetrahedral units. Each tetrahedral unit contains carbon atom at the center, and this carbon atom is linked with another 4 carbon atom placed at the corners of the tetrahedron. Now, carbon atoms of each tetrahedron are also linked by sharing a carbon-carbon covalent bond with the carbon at the center of each of the neighboring tetrahedron. Now, each carbon is sp3 hybridized and each carbon is shared by 4 carbon atoms. Now, the carbon-carbon bond distance is equal to 1.54 Armstrong unit, which is the normal distance of the carbon-carbon covalent bond. Since the diamond has a number of tetrahedral units, it is a giant molecule. Okay. It produces a repetitive three-dimensional structure using only covalent bonds. Now, silicon, germanium, and gray tin are also crystallized in the same way as diamond. Now, here you can just see this is the carbon which is at the center, and this is the tetrahedral unit. Now, this carbon in the center is attached to 4 more carbon atoms which are present in the corners of the regular tetrahedron. Now, see here, this is the repetitive three-dimensional structure. So, this carbon is the center carbon which is attached to 4 more carbon atoms. The same way, this carbon atom, the center one, is attached to 4 more carbon atoms. So, here, this, like this, it goes on. So, this is the repeating unit, and as a result, you get the giant molecular structure. Like here, this carbon-carbon distance only, it's found to be the normal carbon-carbon distance of a covalent bond. Now, let us see about the properties of diamond. It is insoluble in all solvents. Now, due to the giant molecular structure, or you can say structure of diamond, it is a very hard substance. Due to its hardness, it is used in cutting of glass and also rock borers. This is the greater hardness substance ever we have found. Since all the 4 carbon electrons or 4 electrons of the valence shell of each atoms are used in making 4 covalent bond with other carbon atoms, there is no free electron left in the diamond. Hence, it is a bad conductor of electricity and heat because there is no electrons to carry over the electricity and heat in the crystal. Since in order to break the bond, that is the CC covalent bond, a large amount of heat energy is required. Hence, we say that the melting point of diamond is very high. The relative density is also high, which is equal to 3.5. It is transparent to X-rays. It has a value of refractive index as 2.45. Now, At 900 degrees centigrade, diamond burns to give carbon dioxide. It is also slowly oxidized by potassium permanganate and concentrated sulfuric acid at 200 degrees centigrade to form carbon dioxide. So when diamond is heated with the sodium carbonate, it gives out carbon monoxide. It is stable in vacuum up to 1500 degrees centigrade. But when it goes beyond 1800 to 2000, it is converted into graphite. This diamond reacts with fluorine at 700 degrees centigrade to form carbon tetrafluoride. The colorless diamond are used in precious jewelries because of their ability to reflect and refract light. Diamonds are used for drawing of thin wires. So these are the properties of diamond. Now let us move on to graphite. Graphite is found in Ceylon. Manufacture. It is obtained by Atkinson process, which consists of heating a mixture of sand, that is silica SiO2, and coke. And mainly here we use this is anthracite coke in the presence of iron oxide as a catalyst and at a temperature of 3000 degrees centigrade in an electric furnace. Now here the furnace is fitted with two carbon electrodes joined with a thin carbon rod through an alternating current. When it is passed, the reaction between the silica and the coke proceeds as the silica reacts with carbon and it is getting converted into silicon carbide in the first stage. Now this silicon carbide again undergoes decomposition and forms silicon plus carbon, that is the graphite. Structure. The structure of graphite, it consists of large number of flat parallel layers of carbon atoms. Each layer is composed of flat hexagonal rings of carbon atoms. In each layer, each carbon atom is joined only to 3 carbon atoms by a CC covalent bond. Hence, the carbon is sp2 hybridized. So, since it is only attached to 3 carbon atoms, there will be a free electron in the carbon. So, the carbon-carbon distance in a hexagonal ring is 1.42 Armstrong and the distance between the two layers is 3.40 Armstrong. Such a large distance between the two layers suggests that these layers are not joined together by covalent, but instead it is the weak van der Waals forces. The presence of hexagonal rings in each layer is proved, or it is being supported by the fact that when it is treated with alkaline potassium permanganate solution, it is getting oxidized into malitic acid, that is COOH 6 times, and oxalic acid. So malitic acid or distillation with lime gives benzene, that is C6H6, which proves that the structure of graphite is hexagonal. See here, this is the structure of graphite. See here, this is the hexagonal structure of graphite. Now here, these graphites are arranged in the hexagonal form and they are arranged in layers. This is the first layer, the second layer, and then the third layer, it goes on. So now here, the distance between these two layers is 0.34 nanometers, or you can say it is 3.4 Armstrong. The distance between the carbon-carbon atom is 0.14 nanometer, or it is 1.4 Armstrong units. Now here the force between these two layers are nothing but it is the weak van der Waals forces. Since they are present in layers, they can slide over one another, and as a result we say that it is having a greasy appearance. The next we'll move on to the properties and uses. Since van der Waals forces with the layers the carbon are held together are weak, this graphite can slide over one another, and hence graphite is soft and has a lubricating property. Then carbon is linked to 3 carbon atoms, and I told you earlier that there will be free electron left in the carbon. Hence this free electron can carry the heat and electricity, and hence graphite is a very good conductor of heat and electricity. Now due to this electrical and thermal conductivity property, graphite is used in making carbon electrodes, or you can say graphite electrodes. The next one is graphite is very soft and it is black in color, and hence it is used in the manufacture of lead pencils. It is due to the strong covalent bonding within the sheaths that graphite has high melting point, and hence it is used in the manufacture of refractory crucibles which are used for melting metals in the industries. Now at the 700 to 800 degrees centigrade, graphite burns to give carbon dioxide. This graphite also reacts with various mineral acids like concentrated nitric acid, sulfuric acid, even at below 100 degrees centigrade to give graphitic acid. The graphite is used for lining and for making electrodes of electric furnaces. Graphite finds its major use as a moderator. So moderator in the sense it just controls the speed. So since it is capable of controlling the speed of the fast moving neutrons, it is used as a moderator in the atomic reactor. Now what is the difference between diamond and graphite? Diamond occurs in nature in the free state, whereas here mostly it is only artificially manufactured. It is the hardest substance, whereas graphite is soft and greasy to touch. Here it is transparent and high refractive index. It's a non-conductor of heat and electricity. Here it is a good conductor of electricity. At 900 degree it gives carbon dioxide, whereas here at 700 degree it gives carbon dioxide. The relative density is 3.5, here it is 2.3. Diamond has an octahedral crystal structure, whereas this has a hexagonal crystal structure. Diamond is insoluble in all solvents, and here it is insoluble in all ordinary solvents. So based on this, assignments are given as writing a note on diamond and graphite.